today is day 18. We're going to look at some logarithms today. So first thing you need to know is that the logarithm and an exponential equation that we've been studying, those are inverses of each other. So here in the middle, you can see this statement here that if y equals b to the x power, then log base b of y equals x. So we're going to use these two statements interchangeably, so we can convert from one form to the other without hesitation in any problem. So logarithms are inverses of exponential functions. In other words, logarithms undo exponential functions. So we're going to use this today when we have a scenario where an x or a variable of any sort is in the exponent. So an exponential function y equals b to the x power, where b is raised to the x power, we're going to rewrite as log base b of y, and we're going to use our calculators to solve that for x, which is whatever's in the position of the exponent. So some practice converting between the two forms is going to be first. So here we have an exponential equation, and we're going to convert it to logarithmic form. So first thing I would suggest while you're learning how to do this is that you go through and you label each part. So the constant, the number by itself, is the y, in this case 729. The base of the exponent is b, and the exponent itself is x. And then we're going to rewrite that as log base b of y equals x, which is 6. So we're not actually solving anything here, we're just rewriting them. Labeling the next one here, now we have a base of 1/2, an exponent of 3, and a constant or number by itself of 1/8. So log base b of y equals x. So log base 1/2 of 1/8 equals 3. For the last one over here, we have 10 to the 0 power equals 1. Remember, anything to the 0 power is 1. So our base is 10, our exponent is 0, and our y is 1. So we can write this as log base 10 of 1 equals 0. Now, if you read the little note down here, that a common logarithm is any logarithm that uses a base of 10, because it's the most common. So you can actually write this common log base 10 of y as log of y. So we could actually write this as log 1 equals 0, and it's understood that the base is 10. So take a moment and look at your calculator. If you have a scientific calculator, there will be a log button on your calculator. It's normally in the top left-hand corner or on the left side in general. That button is only there to compute log base 10. So a lot of calculators that we use nowadays just calculate log base 10. We're going to learn how to convert things to log base 10 a little bit later. On this side, we're converting from logarithmic to exponential form. So the first thing we're going to do is label them in the opposite form that we just did. So here we have log base b of y equals x. We're going to write that in exponential form. So 81b to the x power negative 1/4 power equals y, which is 1/3. Moving to question number 2 here. We're going to have a base of 625, a y value of 5, and an exponent of 1/4. So 625 to the 1/4 power equals 5. Take a moment, pause the video, and see if you can solve this last one over here. Excuse me, not solve it, but rewrite it into exponential form. So now you should have 12 squared equals 144. I just want to point out that for any of these cases, you can reverse the order of any of them. So you could write 144 equals 12 squared, and that's an equivalent expression. Same way we could write 5 equals 625 to the 1/4 power. Those are all equivalent. So that's rewriting from logarithmic to exponential form. Next up is our change of base formula. This formula will be given to you on your formula sheet for your Ivy Tech final. So in this case, we're going to take a log with a base, and we're going to convert it to base 10. So the log of the base gets converted to log base 10 of whatever the base is. And then whatever's in your parentheses up here is going to get converted to log base 10 of, again, whatever's in those parentheses. So we're converting something with not a common base to be base 10. So in this case, we're going to write our two logs, and then the base goes to the bottom. So I'm going to write the 9 on the bottom because it's the base, the 24 on top. And then I'm just going to type this into my calculator, log 24 divided by log 9. So make sure in this case that you're closing your parentheses. You should get a value of 1.446. Take a moment and pause the video and see if you can compute log base 2 of 15. So log base 2 of 15 actually turns into log of 15 divided by log of 2 in your calculator. Log 15 divided by log 2 gives you 3.907. So 3.907. Here we're going to solve an exponential equation. So in this case, we have this exponent up here with an x in it. So it has a variable in it. We're going to work through this problem in order to solve for x. So the first thing we need to do is isolate the term that has the exponent attached to it. So it could be addition, subtraction, multiplication, division in order to get that term by itself. In this case, the 7 is being multiplied by the term with the exponent, so we're going to divide both sides by 7. It's going to cancel the 7s on the left. We're left with 5 to the x plus 2 power equals 8. Now that we've isolated the term with the exponent, we're going to convert to log form. So you might need to take a moment and label your parts. This is b, this is x, and this is y. So log base b would be log base 5 of y, which is 8, equals x, which is actually x plus 2. So this whole piece right here comes down there. Now, in order to get x by itself, I need to subtract 2 from both sides, making sure that when I subtract 2 from the left-hand side, 2 is not like terms with the log base 5 of 8, so I'm just going to write it out afterwards. So now I've completely solved for x. I want to now use my calculator in order to type this into my calculator. I'm going to go over here real fast. I'm going to have to type log base 10 of 8 divided by log base 10 of 5, All of that's going to go in parentheses and then your minus 2. So this is how you're going to type it into your calculator. Again, we're using that change of base formula. You should get an x value, which is approximately negative 0.7080. Our instructions tell us to round to the nearest 4 decimal places. Also note, this is an important question because there is one similar to it on your final exam. Take a moment and pause the video and see if you can work through the following equation. So first step would be to divide by both sides by 4. It's going to give you 2 to the x minus 3 power equals 4. Convert this to logarithmic form. So log base 2 of 4 equals x minus 3. Again, if you need to label them, please do so. To get x by itself, we're going to add 3 to both sides. That's going to give us log base 2 of 4 plus 3 equals x. And similarly to the last problem, we're going to use the change of base formula in order to type this into our calculators. So in our calculators, log 4 divided by log 2 plus 3. So we're going to want to put this all in parentheses and type this in our calculator. You actually end up with an answer of x equals 5. The majority of the time when we work through problems like this, they won't turn out so nicely, but it can happen every now and again. Using exponentials comes into play when we talk about compound interest. So there's compound interest and then there's simple interest. Simple interest, you get interest earned every year. So you get that payment once a year. With compound interest, you get paid multiple times throughout the year. So your interest is split up between different time periods. And actually, we'll look at it on the next slide, but you actually earn more money that way. So here's the formula. The formula will be given to you on your final exam on the reference sheet. So in this formula, A stands for the future value of your investment or loan, including the interest that you've earned. P is the initial investment, your initial deposit, your initial loan amount. So that's your original amount. R is your interest rate. It must be entered as a decimal. So remember to convert between a percent to a decimal. You're going to move 2 places to the left. So if you're given a percent, move the decimal 2 places to the left. N is the number of times that interest is compounded over the unit t. So a lot of times in these problems, t is represented as years. So the N would be the number of times that you're paid interest per year. So if it's daily interest, that would be 365. If it's monthly, it would be 12. If it's quarterly, it would be 4. Semi-annually would be 2 times per year, things like that. And then, like I said, T is the number of time that the money has been borrowed. So here's a cool little graphic that shows you compound interest versus simple interest there in blue for 10% over 20 years with an initial amount of $1,000. So let's try to actually use this formula here. So we're going to compute the value of an investment after 10 years if an amount of $5,000 is deposited into a savings account with an interest rate of 5% compounded monthly. So we need these four terms over here on the left. P is the initial amount, which in this case is 5,000. Your rate is 5%, which is 0.05 as a decimal. N is the number of times your money is compounded. You'll see that it tells me compounded monthly. There are 12 months in a year, so you're going to earn money every month, so 12 times per year. And then the amount of time is 10 years. So here's all of our information. We're going to plug it into that formula. A equals the principal amount, 5,000, then parenthesis 1 plus the rate divided by the number of times it's compounded per year, N, which I should replace with 12. And then your exponent is going to be 10 times 12. That's the number of times it's compounded per year times the number of years. I've had some students who don't like to put that 10 times 12 up there, and they'll go ahead and multiply those together, and that's fine as well. So you should be able to type all of this information in your calculator all at once if you're using those parentheses. So highly suggest using those parentheses. So my calculator is telling me that the amount that's going to be in the account after 10 years is going to be $8,235.05. Remember, we're talking about money here. Money is always rounded to the nearest penny, so the hundredths place after the decimal. Our second example here, we have a child who receives $20,000. It's going to be invested for 17 years at 7% annual interest, compounded quarterly. So we're going to do so our principal is going to be the initial amount, the $20,000. The rate is going to be that 7% converted to a decimal, 0.07. It is compounded quarterly. Quarterly means 4 times a year. And then the number of years is 17. So the future value, the amount is going to be 20,000 times 1 plus the rate, 0.07, divided by 4, all to the 4 times 17 power. And again, if you're using these parentheses appropriately, you should be able to type all of this in your calculator and get the final amount of $68.44 for that account. Last one here, take a moment, pause the video and see if you can work through this one here. So for this one, the principal, $4,000, the rate, 0.098, the number of times it's compounded per year is 2 for semi-annually. And for this case, the years that have passed between 35 and 27 is 8. So the amount in the account is going to be 4,000 times 1 plus 0.098 divided by 2, all to the 2 times 8 power. So Jill's going to have $8,599.39 in her account after she turns 35.